This assessment asks us how many different chloroalkanes would be produced if we reacted cyclohexane with one equivalent of Cl2. This is not a question really as much about radical halogenation as it is about the equivalence of hydrogens. And so if we look at the hydrogens here in cyclohexane, because cyclohexane is a symmetrical molecule, every carbon is identical. Every carbon, every hydrogen is in the same chemical environment. And so removing any of the hydrogens to make a new chloroalkane would make an identical secondary radical. And so how many different chloroalkanes could be produced in this case? Only one. Regardless of which hydrogen we remove along the ring, if we replace those with a chlorine atom, we would get the same molecule, chlorocyclohexane. That's because cyclohexane has symmetry. Why is this important to NMR? Once again, stay tuned.